So in this video we're going to go over how to calculate the determinant of a matrix that's been derived from another matrix via elementary row or column operations. So in this case we have a matrix A, and it's right here. I don't think I need to read the entries to you. And what I did is I pre-calculated the determinant of A in GeoGebra. So the determinant of A according to GeoGebra was -9. And what we want to do is calculate the determinant of matrices B, C, and D using the properties of determinants that we looked at in video 1 by trying to identify the row or column operation that's been applied to A to generate the matrix B. So in the first example, what we want to hone in on is row 2. And when we look at the row 2 entries from the original matrix A, what we notice is that matrix B has been obtained from matrix A by multiplying 3 times row 2 and then replacing the result in row 2. So 3 times 2 is 6, 3 times -3 is -9, and 3 times 1 is 3. And so if we look over at our properties of determinants, we see that if we scale a row or column by a scalar C, then the determinant of B will equal the scalar times the determinant of A. So in this case, because row 2 is 3 times row 2 of of matrix A, it will be the case that the determinant of B needs to be 3 times the determinant of matrix A. And because we know the value of the determinant of A already, we just multiply 3 times that determinant value to get 3 times -9 is -27. For matrix C, what we want to notice is that columns 2 and 3 have been interchanged. So the 3, 1, 2 in column 3 is now 3, 1, 2 in column 2. And the -2, -3, 2 in column 2 is now in column 3. And when we generate a matrix from another by interchanging rows or columns, then the matrix that results is the opposite of the original matrix. So in this case, the determinant of C, which has been obtained from A by interchanging columns 2 and 3, the determinant of C is going to be the opposite of the determinant of A, is going to be the opposite of the -9 that A is, which is just going to equal a +9. In the last instance that we have here, this one's a little harder to see. Usually if you've applied property 3, where you obtain a matrix B from A by adding a multiple of one row or column to another row or column, that can be harder or more difficult to see. But in this case, what we want to notice is that row 3 has been obtained from row 1 by multiplying -2 times row 1 and adding the result to row 3 in the original matrix A. So up here, if I do -2 times row 1 plus row 3, I get -2 times 1 is -2, plus -3 is -5. I get -2 times -2 is 4. 4 plus 2 is 6. And -2 times 3 is -6. Plus 2 is -4. So the matrix D has been obtained from matrix A by adding -2 times row 1 plus row 3 and replacing row 3 with the result of that summation. So in this case, the determinant values will be identical. So the determinant of D is going to be equal to the determinant of A, which is just going to be equal to -9.